Index law number 3 deals with when we have a base raised to a power, and then that whole thing is raised to another power. In this case, the result is found by multiplying those two powers. Or we could even write this, rather than a to the m times n, we could write that as a to the mn. So to look at a couple of examples of how this would work, let's pick a pronumeral, t, pick a number, 3, and another number, 2. We could work out this by saying, well, t to the power of 3 all to the power of 2 is the same as t to the power of 3 times 2, or t to the 6. Again, I can do this with fractional powers. T to the power of 4 all to the power of 1/3 would be t to the power of 4 times 1/3. And we want improper fractions rather than mixed numerals, so we want to write it as 4/3. And we could even do this with negative powers. Let's go to the 1/4. Okay, this would become negative times a positive is a negative, 2 on 4, and that simplifies p to the negative 1/2. Now, the reason that this works is, again, because of the way that multiplication works and because of what these each denote. Let's take x to the power of 4 all to the power of 2. I don't want two bigger numbers for my examples just yet. So here we have x to the power of 4 all raised to the power of 2. Now, what does this mean? What we're going to do is we're going to treat this inside bracket as just one chunk. It's something raised to the power of 2. And raising to the power of 2 means it's whatever that something is times itself. So in this case, I've got an x to the 4 multiplied by itself, because the x to the 4 is squared. So that's all these brackets are doing, is they're showing that that whole thing is squared. X to the 4 is squared. Now, what do each of these mean? Well, x to the 4 means x times x times x times x, x multiplied by itself 4 times, and this x to the 4, well, it's just going to mean the same thing, x times x times x times x, 4 of them. So in total, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, or 2 lots of 4 x's. So 1, 2, 3, 4, 5, 6, 7, 8 x's multiplied together is the same as x to the power of 8. And of course, the shortcut method for that would be to go 4 times 2. 4 times 2 is 8. And picking a nasty example to show why this is useful, scroll down a little bit. Let's pick some bigger numbers. 12 to the power of 100. Okay. Now, I don't have to just write out all of these y's, okay, because I'd have to do a set of 12 y's and then another set of 12 y's and another set of 12 y's until I've got 100 sets. That would take forever and be a waste of paper and just dumb. So instead, we can just go the shortcut method. 12 times 100, okay, when we multiply by 100, we just tack a couple of zeros on. So it's going to be 1,200. And I don't know about you, but I'm not in the mood to write 1,200 y's across my page, multiplying them together. The index law lets us get to that answer really quickly without having to worry about this intermediate step. So that's index law number 3, where we have some power raised to another power.